Hey Ramblers. Okay, we watched the video on section 4.5 and 5.2 and it gave us a lot of vocabulary. So we learned all about lines and coplanar lines and non-coplanar lines and different angles like alternate exterior, alternate interior, corresponding, same side, a ton of vocabulary. And then we learned about something called the exterior angle theorem. How in a triangle, if you extend one side, you make an exterior angle. That angle is going to be larger than either one of the two interior angles. So what of it? Why did we learn that? Well, you'll realize in this video why we brought that up. It was to prove that if you know certain angles are congruent, then the lines have to be parallel. And you'll recall that the definition of a parallel line is that it's two coplanar lines that never intersect. So I made a sketch for you that kind of explains where how the proof comes about. It's a proof by contradiction, and I think you'll find it interesting. So thanks for watching, and I hope this helps. Okay, suppose we have two lines, A and B, and they are cut by a transversal T. Now you'll recall from the previous video on 4.5 and 5.2 that creates 8 different angles, and one pair of those angles would be angle 4 and angle 6. Now, angle 4 and angle 6, you recall, are alternate interior angles. But let's get to that in a minute. This theorem is going to state that if angle 4 is congruent to angle 6, line A will have to be parallel to line B. So this will be the theorem we're trying to prove. If two lines are cut by a transversal such that two alternate interior angles are congruent, then the lines are parallel. And the proof of it is going to be a proof by contradiction. So let's take a look at it. All right, proof by contradiction states this. Either A is parallel to B or A is not parallel to B. Since we're trying to prove that it is, we'll assume that line A is not parallel to B. If that's the case, then the lines would look something like this. And they would intersect at point P. But this makes a triangle, and you can see that if we get rid of some of the other objects. And by the exterior angle theorem, angle 4 here is now an exterior angle. It's being created by the extension of a side, and it's outside the triangle. So from that theorem, we know that angle 4 must be greater than angle 6. It's also going to be greater than the angle here at P. But for our purposes, all we have to focus on is this. And we know that angle 4 has to be greater than angle 6. But the givens say that angle 4 is congruent to angle 6. So we've reached a contradiction. Therefore, our assumption is false, and line A must be parallel to line B, which is what was supposed to be proven. Okay, let's take one more look at how we can extend this theorem to include other types of angles, like alternate exterior angles and corresponding angles. And we will be able to prove that lines are parallel with a lot more tools. Okay, so let's take another look at this very familiar diagram now of two lines being intersected by a transversal. We've just seen that if the alternate interior angles are congruent, we get parallel lines. So for instance, if I knew that angle 3 and angle 5 were both the same measure, I would know that the two lines L and M were parallel. Well, let's see, what other types of angles is that true for? Let's take a look at alternate exterior angles, like angle 1 and angle 7. Here they're also congruent. And so I can prove that alternate exterior angles, if they're congruent, the lines are parallel. And I can do that since I know that angle 3 and angle 5 are congruent, then angle 1 and angle 7, being vertical angles of 3 and 5, must also be congruent through the transitive property. So that gives us that alternate interior angles imply parallel lines. Well, alternate exterior angles also imply parallel lines. Okay, let's take a look at corresponding angles. With corresponding angles like 1 and 5, those are congruent. 2 and 6, those are also congruent. So if we know that 3 and 5 were congruent, then because angle 1 is vertical to angle 3, I would know that angle 1 and angle 5 were congruent. Well, those are corresponding angles. So if corresponding angles are congruent, we know that the lines are parallel. So there's really more ways to prove lines parallel than just by knowing that alternate interior angles are congruent or alternate exterior angles. Corresponding angles can also be used. Okay, well, how about these same side interior angles? Maybe we can keep some of these theorems over here on the side just as a summary. And let's close that up. Okay, well, the same side interior angles, for example, we have angle 4 and angle 5. Now you'll notice those are not congruent. They're in fact supplementary. So if same side interior angles are supplementary, that can imply parallel lines. And very similarly, if same side exterior angles are supplementary, that implies parallel lines. So here's kind of a sum of all the theorems that we learn in this section, and they're all really important because proving parallel lines will be the main focus of this next chapter and a great tool for you throughout the course. So please get these 5 theorems in your notes, and I hope this video helped.